All right, so today we're going to be looking at electron configurations. Really, these are just really easy ways of depicting where an electron is and how much energy it has. So let's start off just like we did with the electron dot diagram. So let's start off with something with just s and p orbital electrons. All right, so we're going to start with nitrogen. If I wanted to draw an electron dot diagram of it, I would see if I followed all the steps that it looks something like that. Okay, so we need to figure out how do I indicate which number, what shell it's in, what orbital it's in, and how much energy these things all have. So starting off, I need to get to here. So starting off with, I have row 1. Row 1 only has one orbital in it. So I'm just going to write up 1s down here. Okay, tells me I'm in shell 1, the s orbital electron. On the key, you wrote the s orbital electrons get one box, right? And in that one box, we have 2 electrons. And when I spun my arms like a crazy person, spun them in opposite directions, I'm going to, because that was to indicate, yeah, you don't need to see my steam, which direction these electrons are spinning. And really to indicate that with this diagram, we just use arrows, one pointing up, one pointing down. Spinning in opposite directions, they're able to get way closer to each other. So now that took care of these two here. So now I'm down here, I'm in row 2. I'm still working with those s orbital electrons. So right above 1s, I'm going to write 2s. And the s's still get one box. And I'm going all the way through it because my job's to get to here. So I have 2 electrons in there. And use arrows to indicate each one and how it's spinning. So now I'm over to here. These you colored red because these are p low orbital electrons. You also wrote down that p orbital electrons stay in their row, so we have 2p. But rather than writing it directly above it, I'm going to indent in a little bit. So let's go 2p. You also wrote down that the p orbitals get 3 boxes. All right, I made that middle box a little bit rough, but that's all right. And so in that 2p, I'm only going to count these right here until I get to nitrogen. 1, 2, 3. And I want these to be as spread apart as possible. So let's go 1, 2, 3. So it's important to see that nitrogen has these 3 unpaired electrons. And if I'm looking at row 2 altogether, or shell 2, I see that I have 1, 2, 3, 4, 5 electrons, 1 pair, 3 unpaired. And when I look up here, I can even see 1 pair, 3 unpaired electrons. Now you might be asking, do I always have to put them going in the upward direction? The answer is no. Really, those can go in any direction. You know, if I wanted to start with downs, that's fine, so long as I didn't make my 2p up, down, up. That I can't do. They have to start all going in the same direction, whether it's up or down. Like I could have gone 1, 2, 3. That would have been okay. Or putting them all up, that's also okay. So long as they're going in the same direction. Just because that's what the electrons actually do. Really, this just kind of gives us information about the electrons that we're going to talk about in class. But electron configurations, that's how you do them. Should be pretty easy. If you have any questions, feel free to let me know. Otherwise, good luck.